Okay, so this is 2012B. The reason we're doing this is because it's a going down the plane one. So revise that, and there's also a bounce. So a particle is projected down an inclined plane with an initial velocity of 20. The line of projection makes an angle 90 degrees with the inclined plane. So it goes off at 20, that's 90 degrees. And it says the plane is inclined at alpha degrees to the horizontal. The plane projection is vertical, contains the line of greatest slope. Particle strikes the plane at Q and it rebounds. Okay, so we can see in the diagram that it rebounds. The range of the particle is 1600 root 3 over G. You've got to find the value of alpha. Okay, so let's draw up the table, IJ table, the U. Okay, so because it's sent off at 90 degrees to the plane, that means that it doesn't have any I component, it only has a J component. So this would be 0I plus 20J, so 0. Now, this the 20J, of course, comes from the fact that it's the sine of 90. So this would have been 20 cos 90, and here we have 20 sine 90, and of course 20 sine 90 is just 20 because the sine 90 is 1. Minus G. Okay, so here's the G. I'm going to break into its two components. Remember this one, this angle here will be alpha, so this component here will be G cos alpha, G sine alpha. So my A for the I component is minus G sine alpha, and this is minus G cos alpha. So what's the V? Now, the fact that it's coming down the plane means that this minus is going to be changed to a plus because it's a directional sign. So this is U plus AT, U plus G sine alpha T. And this one will be U plus AT. The S will be then UT plus a half AT squared. I'll forget about the UT. So that's a half G sine alpha T squared. And this will be UT plus a half G cos alpha T squared. Okay, we have to find the value of alpha. So what do we know? We know that the S of I is equal to 1600 root 3 over G when the Sj is equal to 0. The SI is a half G sine alpha T squared. So we'll put that equal to 1600 root 3 over G. And when the Sj is equal to 0, this is 20T is equal to a half G cos alpha T squared. If I cancel or divide all the across by T, sort that equation out, it becomes 40 over G cos alpha. So that's my T. Right, what I'll do is I'll sub that T into this equation here. So this will become a half G sine alpha by T, which is 40 over G cos alpha, all to be squared, is equal to 1600 root 3 over G. So a half G sine alpha by 1600 over G squared cos squared alpha is equal to 1600 root 3 over G. That G will cancel with that square. Those G's will cancel under the line. Those 1600s will cancel above the line. So I now have sine alpha over cos squared alpha. I'll take over that 2 is equal to 2 root 3. Okay, I'll cross multiply here. Sine alpha equals 2 root 3 cos squared alpha. Now, how will I solve for this? No substitution will do me. Let's see if I say sine squared alpha plus cos squared alpha is equal to 1. So if I use this and said that the cos squared alpha is equal to 1 minus sine squared alpha, then I'd have a nice quadratic. So that's what I'll do. I'll say sine alpha equals twice root 3 into 1 minus sine squared alpha. And when I sort all that out, my quadratic will be twice root 3 sine squared alpha plus sine of alpha minus twice root 3 is equal to 0. Okay, so I'll use the minus b formula. And this will give me a sine alpha is equal to minus b plus or minus the square root of b squared, which is 1 squared, minus 4 by a, twice root 3, by c, which again is minus twice root 3, all over 2a, which will become 4 root 3. Now when I work out that inside the square root, it becomes root 49. So this is minus 1 plus or minus 7 over 4 root 3. So minus 1 plus 7 over 4 root 3, minus 1 minus 7 over 4 root 3. I won't use this one, it's negative. So this will become 6 over 4 root 3, which of course is 3 over 2 root 3. Okay, so the sine of alpha is equal to 3 over twice root 3, which means that alpha is 60 degrees. Okay, so that's the first part. Now the second part says, find the magnitude of the rebound velocity at Q. So here again, we're going down the plane, you bounce on the plane and then you rebound. So this rebound velocity will be Vi plus Vj. I need the magnitude of it. So first of all, I'm going to have to find the incoming velocity. So I want the velocity of the Vi and Vj of the incoming velocity. So you want the incoming velocity, and once you've got that, then you can get the rebound velocity. So the incoming velocity, Vi plus Vj, when the time of flight is evident there. So where's that sheet gone to now? The t is 40 over g cos alpha. 40 over g cos alpha. And of course the cos of alpha is cos 60. 40 over g cos 60 is 40 over g by half. That's 80 over g is my time there. Right then, incoming velocity then. So back to this. My Vi is g sine alpha t. So this one will become g sine of 60 by t, which is 80 over g. So that's the I component. The j component will be 20 minus g cos alpha t. 20 minus g cos 60 by t, which is 80 over g. That's the j component. Okay, so when I work this out, the sine of 60, remember, is root 3 over 2. So this becomes 40 root 3, the i's, the g's will cancel there. Now, when you work this one out here, the cos of 60, that's going to be a half. The g's will cancel. So this will be 20 minus, that will be 40 in the j direction. So that's 40 root 3i minus 20j. Okay, that's your incoming velocity. Right, so it hits with that velocity. Now the bounce velocity, the rebound velocity. Remember this plane, it's an I-axis plane. So that means if you have AI plus BJ strike for the rebound, that's going to be, if it's an I-axis strike, be AI minus EBJ. And I'm told in the question that the coefficient of restitution, E, is a half. I'm told that already. So this is my incoming velocity. I'm going to apply this to it and get the rebound velocity. So the rebound will be 40 root 3i. That doesn't change. That will change to plus 20, half by 20j. So this will become 40 root 3i plus 10j. And then to find its magnitude, the magnitude, that's going to be the square root of 40 by root 3, which is 1600 by 3. That's all to be squared, plus 10 to be squared, which is 100. That's 48 plus 49. So that's going to give you square root of 4900, which of course is 70 meters per second. So that's the magnitude of the rebound velocity.